Hi, my name is Michael Thompson, and we're going to be going over the tangent function today, and how to graph it. So first start with our a, b, h, and k values. So as you can see from this equation, y equals -2 tangent of 3x plus 3, that your a value is going to be -2. Because you can do, from my last video I showed that you could do a tangent bx minus h plus k. So now we'll look at our b value. Our b value would be 3. Because as you can see, it's going to be right there. Our h value, now, we don't necessarily have an h value. See, it's just only 3x. If there was an h value, it'd be 3x minus a certain value of some sort. So we don't have to worry about that. We can just put 0. Now we look at our k value, and our k value is going to be 3. So now after we do that, we have the amplitude, which we know is going to be the absolute value of a, which would equal 2. And see how that's different. That's where I get confused sometimes is, I always think that a value always equals the amplitude, but you have to know that the amplitude is going to be the absolute value of a. So now we look at our period, which is 2 pi over the absolute value of b, and that would be 2 pi over 3. So that would be your period right there. Now we can look at our width, and our width, using our h value, we can say that we have 2 pi over 12, and you would end up getting pi over 6 as your width. Now, for your first tick mark, it's going to be 0 because you start with your h value. So you have 0 right here. Sorry, I'm trying to make it, there we go, that adjusts a little better. You're going to have 0, and then for your second tick mark, it's just going to be pi over 6, because it's just 0 plus your width, which is pi over 6. Then your third tick mark will just be pi over 6 plus pi over 6, which would end up giving you pi over 3. Then your fourth tick mark, pi over 2, and 2 pi over 3. So now that you have these values, now you can start looking at what you put on your y and x values. So as you can see in the previous video, that your a and your k values are going to be put in that will affect your y-axis. So if we look at our k value, we have 3. So we're going to go 1, 2, 3. But we have an amplitude of 2, meaning that you have to go 2 up. Since you have 3, it goes 1, 2, and that would be your minimum. So you have your minimum at 1 and your maximum at 5. So after you show that, now what you have to do is you have to put on your tick marks, which go on the x-axis. So I'm just going to set them right here, exactly what we did right here. We're going to do pi over 6, pi over 3, pi over 2, 2 pi over 3. Sorry, you can't see it as of right now. Let me just, because I'm lefty. And, we have 7 pi over 6. And we're just going to extend it, so 4 pi over 3 and 3 pi over 2. And yes, I'm kind of extending it a little bit here, but you can see that. Sorry, it's a little blurry. Get my camera to adjust. There we go. So now that you see that, now we can start looking at our function. So now you know it's a tangent, which means you're going to first start by looking at the cosine function. And you just technically put the graph of the cosine function. It's just to help you figure out the tangent. So tangent goes with cosine, and then you would go cotangent goes with sine. It's just the opposite. So now you look at this, and we could also say that origin's right there, so we can make that a dashed line across. And then so let's just do the dots for the cosine function first. So we know that our value is going to start at 3, because that's where it was brought up. Then you're going to put dot right there on 6, and then it goes all the way back down to pi over 3, and then it goes back down to our minimum at 1 at pi over 2. And you can just draw the dots. We don't need to draw the line because it would kind of look a little confusing when we draw the tangent function. And we can say so let me just draw this real quick. So now that you have your dots right here, now you can kind of see where everything goes. So now we need to draw our asymptotes. And we know that our asymptotes are going to be on the parts that are close to pi over 2. So we're going to have an asymptote there, our asymptote there, our asymptote there, our asymptote there, our asymptote there. So now that we have our asymptotes, now you can see that we need to start